Hi, today we will be doing the introduction of microcontroller and embedded system. In microcontroller and embedded system, this is the basic intro or basic structure in which we are discussing CPU. I will be explaining how input and output devices and memories are connected to CPU using a bus system. In this bus system, we have address, CS control signal, OE data, and this is data line with W, and this is with respect to time. In this IC, we have a ground and VCC from where the signals, from there the IC receives the voltage and the ground. D0 to D7 are registers which are receiving 8-bit inputs, input and output. The both of the arrows shows that input and output both are being received and sent. This shows n bit, the number of bit the data is transferring. Again, this is a register with a name. We have other pins which are for the data transfer and address control. A general CPU have mouse, keyboard, sound card, graphic card, and network. This is how a general PC works. Now in this, we are discussing input-output devices. Here you can see on this side we have input output 0, 1, 2, and so on, as many inputs you want. Then on this side we have address bus, data bus, and control bus. What is an address bus? Address bus is used to select a specific device or memory location. Um, Such as here it is addressing input output position 0, position 1, 2, and so on. For example, if you want the CPU to communicate with input output 1, it sends a unique address on the address bus like this. Only the devices whose address will match will correspond to the data bus. Now, what is a data bus? A data bus is the one which is carrying the actual data between the CPU and the input output. Whatever input output you have connected, it is carrying that data to the CPU. If the CPU is performing the read operation, data flows from, if it is reading it, data is flowing from input output to the CPU. It is reading something from the input output thing. And if it is performing the write operation, the control bus write will be basically detecting the data flow from the CPU to the input output device. Whatever data is being written on there, it is being read by the input output device. So this is why a control bus is bidirectional, which is this. Now a control bus can do both. You can see this one. This is a control bus which is doing both. So if the read signal is active, if you have activated the read signal, the device sends the data to the CPU. However, if the write signal is active, the CPU sends the data to the device. The control bus ensure proper timing and coordination of the operations. So this control bus is basically controlling what data to write and what data to read. This is how it will manage the overall selection or the data organization. Now, the next thing that we have is this is basically a decoder. Inside it, it is a decoder, and we have a chip select CS. The chip select is basically used to select or activate or decide what address bus will activate the chip line of one device. Now, in microcontrollers, this concept is important because we have limited pins. So, in order to manage, just like this is a register. Now we have limited pins. In order to manage with the limited pins, we need many peripheral connections, and these peripheral connections work efficiently when you have done the proper mapping of input output device with the read and write. So generally how a CPU works is by communicating the memory and input output device in conjunction. The address bus is going to select the device. Data bus is going to transfer the data to the device. Now it depends what kind of data you need to transfer. Either you need to write or read the data. If you want to write the data, um, you will be sending the data from CPU to the input output. If you want to read the data, input output will be sending the data back to the CPU. So this is all for now. Thank you.